In this video, what we are going to see is that the most common type of problems what you can expect in LPP. Alright, so we have manufacturing problems, we have diet problems, we have allocation problems. Different types are there. Let's solve with the first one. Now look at the first one. See, a manufacturing company makes two models, A and B of a product. Each piece of model A requires 9-hour labor and fabricating and 1 hour of finishing. Alright. Each piece of model B requires 12-hour labor and fabricating and 3 hours of labor for finishing. For fabricating and finishing, the maximum labor hours available are 180 and 30 respectively. Right? The company makes a profit of 8,000 on each piece of A, 12,000 on B. How many models of A and B should be manufactured per week to realize a maximum profit? What is the maximum profit? There's a lot of information on this one, correct? You need to segregate it properly. Okay, now let's start with the very basic part, that is what we need to pick. We'll look into that one. Okay, now here there are two models, correct? So first what we'll do, so the first one, let X be the number of things in model A. You can say that product, and Y is from model B. All right. Now, what do we need to maximize? Look at the question. The question says, so it should be manufactured to maximize the profit. So, profit is going to be my function, correct? The objective function is profit. So, profit Z. I need to maximize this. What is the cost? This 8,000 on model A, 12,000 on model B, correct? So this is going to be 8,000x plus 12,000y, right? Now let's go for the next one. See, what do we have? 9 hours, 9 labor hours for fabricating, right? The next one, model B requires 12 labor hours of fabricating. Now let's look at it like a fabricating constant. Okay, only fabricating constant. Then we'll go for the next part. Now for the fabricating constant, we have 9x plus 12y, correct? So what do we have here? Now for fabricating and finishing, maximum hours available are 180, correct? So for fabricating is 180, less than or equal to 180, right? Now after this, what is the next part? For the finishing. For the finishing, see, what is the finishing? 1 hour labor force for the finishing for model A, and then 3 labor hours, correct? So what do we have now? X plus 3y less than or equal to, we have 30 hours. 30, right? Then finally, the constant, that is x is greater than or equal to 0, y is greater than or equal to 0, correct? So these are the things what we have. Now that you have framed an equation, the next part what we need to do is drawing the graph. All right. Before the graph, now what do we need to do? Let's simplify. See this 9x plus 12y? We can also write this as 3x plus 4y less than or equal to 60. And this is nothing but x plus 3y less than or equal to 30. Right? Now let's do the plotting of the map, as in plotting of the straight line. See the first equation. The first equation what we have is 3x plus 4y is equal to 60, correct? So we have the first equation, this one, 3x plus 4y less than or equal to 60. We take the equal to sign, correct? Suppose if when x is 0, so what do we get? Suppose if x is equal to 0, then y is equal to 15, y is equal to 0, x is equal to 20, right? So when x is 0, y is 15, Next, when y is 0, x is 20, right? So now let's draw the line. So the first point is going to be here and the second point is going to be here, right? This is the first case. Now for the second case, what we have is that x plus 3y less than or equal to 30, right? Or we can take x plus 3y is equal to 30 when x is 0, oh sorry, 30. When x is 0, y is 10. When y is 0, x is equal to 30. Correct? Now when x is 0, y is 10. The next one is going to be 30 somewhere over here, right? Now again, so you take this here, you're going to take this here. So this is the line, correct? Now what do we have? We need to figure out the area. So the area is going to be this. See, this is the line. And this is the feasible region, isn't it? So since this is the feasible region, we need to find the corner points and get the area done. So what do we have now? This is point A, this is B, this is C, and this is O, correct? Now let's solve. See, point A, we already know. Point A is nothing but 0, 15, right? Now we need to just figure out the value of B, right? Now A is nothing but 0, 10. C is going to be this point, which is 20, 0, and O is nothing but 0, 0. And when you solve the two equations, you'll get B as 12, 6. All right, 12, 6. Now what do we have? We have the profit function, the objective function. Substitute these values. Now if you substitute, the function is right here, 8000x plus 12,000y, correct? The first one, if you put A 0, 10, 8000 into 0 is 0, 12,000 into this is 12 followed by 4 zeros, which is 1,20,000. If you take 20, 0, then it's going to be 16 followed by 4 zeros. Then this is 0 anyway. But if you take 12, 6, that's 8000 into 12 plus 12,000 into 6, which gives us 168,000. Now, if you look at it, the maximum value is nothing but this. So, the maximum points, or what we call as the corner points, will be 12, 6. So, how do we answer this one now? Because we got 12, 6, right? So, final answer we can write the maximum value is 168,000, correct? This is a maximum value. So how many product A and product B should be there? So product A, there should be 12 quantities of product A, and product B, there should be 6 quantities of product B. Now if you take this, that is 12 quantities of product A and 6 quantities of product B, we can maximize the profit, and the profit value is this 1,68,000. Understood? So this is one type of problem and one problem. Now let's do the second one. See the second problem. See here, one kind of cake requires 200 gram of flour and 25 gram of fat, and another kind of cake requires 100 gram flour and 50 gram fat. Find the maximum number of cakes. See, maximum number of cakes which can be made from 5 kg flour and 1 kg fat, assuming that there is no shortage of the other ingredients. Okay, fine. The last part is not really that important. Again, of course it is, but not in the context of the statement and the mathematical formula what we are going to write. All right. So how do we go about it? So first we need to assign the variables, right? The decision variables. See, for the second one, there are two kinds of cake, one kind and the second kind. Correct? So let's call it as A and B. Things makes it a lot more easier. Say A is the first one, or we can call it as X and Y because they're asking you how many cakes are there, right? So A is the first kind of cake, and we can make X number of cakes with this one. And B is the second type, and we can make Y number of cakes with this. All right. Now, what are the things we need? We need flour and fat. So the first one is the flour, and say this is the fat. Now we have A and B, which is basically X and Y. Correct? Now for A, we need 200 gram of flour and we need 25 gram of fat. Well and good. For B, we need 100 gram flour, 50 gram fat. So here, what is the total we have, like the availability? 5 kg. 5 kg is 5000 gram. And here this is 1 kg, 1000 gram, correct? Now if you try to make a formula, more like a mathematical equation out of it. So first what do we have? We have 200x plus 100y less than or equal to 5000. 200 into x, correct? 100 into y is equal to this one, 5000. Isn't it? So we got the first constraint, more like, yeah, you can call it as a constraint or condition. The second condition, what we have, 25 into x plus 50y less than or equal to 1000. Same logic, correct? See the first equation, guys, we can simplify this one. See here, you can take 100 common, 2x plus y. So we'll just call it as 50. Yeah, quite simple. Because I'm dividing by 100, right? The next equation is going to be divided by 25. So x plus 2y is equal to, when you divide by 25, it's 100 into 4, sorry, 100 into 10, that's 40. Now we have the two equations. Once we have the two equations, of course, the two constraints, x is this, y is this, correct? We have the two constraints and we have the conditions, we have everything now. The next thing is what? Plotting the graph, correct? See the first part what we have, 2x plus y is equal to 50, correct? Suppose if x is 0, then y is 50. Now y is 0, x is 25. Now we'll join these two. So this is 1 point, or this is one more point. 2 points are done. So this is the first line, right? The second line is 2x, sorry, x plus 2y is 40, right? Suppose if x is 0, y is 20. So if x is 0, y is going to be 20. When y is 0, x is 40. Draw the line, right? So we have two of them. Now we need to find the area. See, this is the area, the feasible region. Correct? This is the feasible region. Now the points what we need to take is nothing but, see, this is A, B, C and O, correct? Now we can calculate, see, A and C very simple. We have to calculate B the same way. Now point A, so point A is nothing but 0, 20. And point C is going to be, so in this case, it's going to be 25, comma 0. The next point, which is O, 0, comma 0. Very simple. Now point B is the intersection. If you calculate, the B value will become 20, comma 10. Alright, now we have the points. But guys, have you noticed we have not even written the objective function? Correct? See, we need to have maximum number of cakes, right? Which is nothing but x plus y. That's a plus b, right? So maximizing function is z is equal to x plus y. So let's apply these values. X plus y. The first one is going to be 20, 25, 0, 30. Right? So the maximum one number of cakes is this. The maximum number of cakes is 30. And the optimal solution, what we don't need the 20 and 10, correct? So what we need is maximum. So this is going to be the answer. Maximum number of cakes is equal to 30. Fine. So this is the answer for the second question. Fair enough. Now let's do the third question. See the third question. Manufacturer produces nuts and bolts. Fine. It takes 1 hour of work on machine A, 3 hours on B to produce a package of nuts. It takes 3 hours on A, 1 hour on B to produce a package of bolt. Alright. He earns a profit of 17.5 rupees per package of nuts, 7 rupees per package on bolt. How many packages of each should be produced each day so as to maximize his profit if he operates his machines for at the most 12 hours a day? Correct? A lot of constraints. First, we'll define the variables. That is our first step. So what we'll do, we'll say that let the number of nuts be x and number of bolts be y. Very simple. Now let's make a table just like what we did in the previous problem. Just like that, we'll make a nice table. We'll get it done. Okay. So now what are the things we have? We have nut, we have bolt, we have machine A, we have machine B. Correct. So we have machine A and we have machine B. So we have nuts and bolts, right? So we have, this is X and Y, correct? Now let's start with the given info. See, the given information is what? It takes 1 hour of work on A and 3 hours on B to produce a package of nut. So 1 hour in A, 3 hours in B. Then it takes 3 hours on A, 1 hour on B to produce a package of bolt. So here it's 3 hours, 1 hour, correct? So to produce now the maximizing function, optimizing function, or you can say the objective function. There's a package of the nut will cost 17.5, whereas the package of bolt will cost you just 7 rupees, correct? And see this maximize. So we are maximizing the profit. Z is equal to 17.5x plus 7y. And guys, remember, we need to maximize this one. Make sense? So, now what do we have? This is the part. Okay, well and good. But if you look at one last thing is there, which is very, very important here. That is 12 hours a day. Extremely important part of the problem. Because we have the nut, we have the bolt, we have how many packages has to be done, everything. But time, availability is how much? It's only for 12 hours a day. Correct? So we have the last part, availability. Fine? 12. Because it says 12 hours a day. So availability is just 12 hours. Now with this information, we can make a small equation. Very simple equation. See the first one, it's going to be x plus the next part 3y is equal to 12 and 3x plus y, correct? 3x plus y is equal to 12. And of course, x is greater than or equal to 0, right? So now we have these two x and y conditions. Now after this, what do we do? First, we have these values. Of course, guys, this is less than or equal to, okay? Don't take it as equal to. It's less than or equal. Now that we have these conditions, or you can say criteria, now we have to draw the line, get the corner points, and maximize whatever we have, right? So first we'll solve and then put it on the graph. Look at the first equation. See, we have x plus 3y is 12, correct? Suppose if x is 0, y is 4, correct? Y is 4. Now, if y is 0, x is 12. Now, what do we do? So, we take these 2 points and we are going to make a nice line from these 2 points. So, this is 1 and this is 1. So, this is the first line, right? Now, the second one, again, if x is 0, y is 12. And then when y is 0, x is 4. Now, what do we do? So, we take this, and then join, right? So, what do we have? We have this to be the feasible region, isn't it? This is a feasible region. So, what do we have? This is A, this is B, this is C, and this is O. Now, point A, first point, which is nothing but 0, 4. Point B, we don't know, we can calculate. And if you do calculate, guys, it's quite simple. You'll get 3, 3. Very simple. All right, then next point C, 4, 0, and point O is 0, 0. Right? So now what do we do? So we put these values. What is my Z function? 17.5 into X plus 7Y. We are trying to maximize, right? The first one is going to give us 28, because 0, right? The second one, 3, 3. This will give us 73.5. Okay. Then the next one is going to be 4, 0, correct? So 4 into 17.5. The next one is going to give us 70. Next one is 0, right? So what do we have? The maximum value is going to be in this one, isn't it? So this is the maximum. So maximum value is going to be 73.5 and 3, 3. So that means we have the nut and bolt. So nuts, we should have 3 packets, and bolts, we should have 3 packets. Then we are going to make a profit of 73.5 rupees. Fair enough? So this is the answer for this question. Now let's do the next one. See the fourth problem. A diet is to contain at least 80 units of vitamin A, 100 units of minerals. Two foods F1 and F2 are available. F1 consists of, F1 costs 4 rupees per unit food, and F2 costs 6. 1 unit of F1 contains 3 units of vitamin A, 4 units of minerals, and that of F2 is 6 units of vitamin A and 3 units of minerals. Formulate this as an LPP. Find the minimum cost. Remember, minimum cost for the diet that consists of mixture of these two foods also meets the minimal nutritional requirements. Don't you think it's a very practical type of problem? The doctor will say, you need to do this one, you need to eat this, you need to eat this. But then you also have to minimize the cost. So let's do the math here. All right. So the fourth one. Now see what they're saying. Find the minimum cost, of course, that contains the mixture of these two foods. Right. So let's say the food, whatever we are going to eat, that has X quantities of F1 and Y quantities of F2. Fair enough? So we know that we have X and Y. Now let's make a table. See, what do we have? We have food A. Okay, F1 and F2, which is nothing but X and Y. So the next thing, we have vitamin A, we have mineral, and we have the cost. Three important parameters. So for the first one, F1, we have how many units? So we have 3 units of vitamin A, 4 units of minerals. 3 units of vitamin A, 4 units of mineral. And what is the cost? We have 4 rupees per unit, correct? Likewise, if I take it for the second one, F2, now here we have, and it is going F2, 6 units of vitamin A, 3 units of minerals. 6, 3. And the cost of this one, so we have F2 cost 6 rupees per unit. 6 rupees per unit, correct? Now, this is the information what we have. But remember, we can get the constraints. We also need to get the objective function, isn't it? So let's do the math now. See what we have. First is we need to minimize the cost, correct? That means my objective function 4x plus 6y. This we should minimize. The cost has to be minimal. But there is a catch. See, the diet should a diet is to contain at least 80 units of vitamin A and 100 units of vitamin mineral, correct? So if I try to write the constraints, we have to be a little more careful. Okay, the first one, vitamin A, it should be at least 80. At least 80, correct? That means the first part is going to be nothing but 3x plus 6y is greater than or equal to 80. Understood? Next, at least 100 units of minerals, which is 4x plus 3y greater than or equal to 100. Fine? And of course, the other two things, x greater than 0 or greater than or equal to y greater than or equal to 0. Correct? And here we have. Now let's draw the graph, taking the equations into consideration. Let's solve the graphical method now. Now let's do the math for the first one. See, 3x plus 6y is equal to 80, correct? See, the first one, 3x plus 6y is equal to 80. Now when you do this, see, when x is 0, we are going to get y is equal to 80 by 6, which is not divisible, right? Which is nothing but 40 divided by 3. So the first point is going to be 0, 40 by 3, somewhere over here. The next one, if y is 0, then x is 80 by 3, somewhere over here. Now again, when you take the line, so one line comes here, one more point will come here. So join them. This is going to be the first line. If you take the next line, 4x plus 3y is equal to 100, right? Suppose if x is 0, then y is 100 by 3. So 100 by 3, maybe somewhere over here. This is 100 by 3. Now, if y is 0, x is 25. So x is 25. So somewhere around here only. You'll get some very close point. You'll get somewhere over here. So 1 point. One more point. All right. So here we have. But guys, you need to understand that it's not a bounded region at all. It's an unbounded graph because it's greater than, right? See, when it is greater than, what we are going to get? We are going to get this region. All right. Since we have an unbounded region, So what we do is we take the corner points. Okay, so we are gonna take this one A, we are gonna take B, we are gonna take C, small points. Alright, so now A is going to give us 100 by 3, 0, 100 by 3. Next, B is gonna give us 80 by 3, 0. Right, so that small point of intersection, we have a small point of intersection. Okay, it's not really clearly visible in the graph, but we have a point of intersection, small. All right, and that point is 24, 4 by 3. Now if we have 3 points. Okay, since we have 3 points, now what do? We take this, remember, z value we need to minimize, right, which is 4x plus 6y. So we need to minimize this. We'll substitute the values, check which is going to give us the minimum value. Okay. Now let's put the values and figure out what is going to be the value of the function. Okay. See the first one, if you put it, so you'll have 0. Of course, the first point A is 0 plus, sorry, A is equal to 0 plus 6 into 100 divided by 3. 600 divided by 3. Right, which is 200. Well and good. Now point B, if you take 4 into 80 by 3, 4 into 8 is 300, 320 by 3. I think this is going to give us 106.6 bar, right? Now C, if you take, now this is going to be 24 into 4 plus 6 into 4 by 3, correct? Now for point C, we have 4 into 24 plus 6 into 4 by 3. Cancel off these two. So 4 into 24 plus 4 into 2, which is nothing but 4 into 26, correct? Which is going to give us 104. Now guys, remember, we are trying to minimize, not maximize, isn't it? So minimum value is 104. And for which one? For point C. So we can say the minimum cost is 104. And how many units of F1 and F2 should be there? Now whatever we have got is the minimum cost, correct? So this is what we were trying to minimize. And also it meets the requirements, correct? So whatever we have discussed so far, guys, these are the type of problems what is expected from you. Now always remember, try to figure out what are the constraints. Try to figure out what is the objective function, and also try to figure out how to plot the graph, because I showed you an unbounded graph and a bounded graph both, correct? So these are the type of problems what you have in linear programming.